Recording in progress.
Hey, so I just want to reassure you that you are not too far behind. A lot of what we've done the last couple weeks or last week or so has just kind of been a review. So I'm going to just go through it really quick just so you kind of have a general idea. Then when you get back, you can kind of fill in the notes but not feel so lost. So I'm doing it with my fingers, so please ignore if it's horrible handwriting. But so we just started working on polynomials. Polynomials are those things like you have like x squared plus x plus 3. Okay, so that's the kind of stuff we're doing. So we have a couple different things we want to do with it. So first thing we're doing, oh, let's see if I can do this right. Nope, hold on. There we go. Okay, so we are talking about adding and subtracting. So if I had something like this, the plus sign in between, what this plus sign means right here is I just want to add like terms. So I can actually just kind of pretend that these are not there. Okay. So then I'm just going to look. So I have my x squared here. I don't have any other x squared. So I'll drop that. I personally like to cross them out just so I don't get them confused. Okay. Now I have this x and this x right here. So that's going to give me positive 2x. And I'm done. And then I just have these numbers right here. So I have plus 5. Okay, so that's not too bad. We're just combining like terms. So next we learned about subtracting them. So I'm going to say I have x squared plus 3x minus, let's actually make this a 3. And I'll have x squared minus 2x. Okay, this is where a lot of people do get confused. So this right here means I'm subtracting the whole thing. So what I usually like to do is we want to distribute that negative. So it needs to go here and here. So I'll either rewrite it or just kind of change the signs. So what this really means is 3x squared plus 3x plus a negative x squared and a positive 2x. Okay, so that just changes the signs. And then we can just, again, drop our parentheses and combine like terms. So I have this 3x squared, oh, come on, this 3x squared here and a negative x squared here. So I'm going to have 2x squared. Done, done. Next, I have the 3 and the 2, so that's going to give me a positive 5x. So just make sure that you do want to distribute this negative, because if you don't, I would have had 3 minus 1. Well, I guess it would be just plus if that were there. So you can see how you could easily make sign mistakes with that. So be really careful. Okay, next, let me erase all these. Next, we did multiplying. So if you remember, multiplying would be something like this. So there's not going to be a sign in between. There are a couple ways to do solving. The easiest, if you remember, is the box method. Okay. So what I want to do is I need to put both of these, one on the top and one on the side. It does not matter at all where you put them. I'm going to put that one there. And I'm going to put this one here. And now I'm going to multiply. So I'll have 2x times x gives me 2x squared. And I'm going to go across. I have 2x times 2, which is 4x. Now I'll move down. I have 5 times x gives me 5x. And then last I have 5 times 2, which is 10. So I could pull out all these numbers and write them individually, then combine like terms. But the secret to this is these numbers, these diagonals, will always be the same like terms. So how I pull that out is just like this. and I just combine those like terms. Okay, just like that. I want to show you another example if we had 3 terms. Okay, so if I had, say, x squared plus 3x plus 4 times x plus 1. Okay, I would still do the box method, but I would do one like this. Okay, so I would just need to add another row. So then I would have x squared, 3x, 4, and then x and 1. And then I would just go through and I would multiply just like I normally would. Okay, so I'll hurry and do that. Oops, that was not correct. That's actually 4x. Oh, come on. And 4. So if you see, these are both x squareds, and these are just plain x's. So this would be x to the third plus 4x squared plus 7x plus 4. Okay, so there are some special rules that we also learn when it comes to multiplying. I did not think to grab the notes on that before I came down to make this video. So I'm going to try and do it one of the examples just from memory. So don't kill me if I don't have them perfectly right, but I kind of just want to show you the process. So there are a couple different things, or special rules is what we call them, special products, where we don't actually have to draw the box and multiply it out. We can, it's totally possible, but these certain ones, we have these kind of shortcuts. So one I have, the one, I think this is the only one I have memorized, is if I had x plus 3 cubed. So what that means is x plus 3 times x plus 3 times x plus 3. So that would require me doing 2 boxes. And so I'll kind of show you what that looks like. And I'll just try to be super quick. X squared, 3x, 3x, 9. So I have x squared, oops, plus, good grief, it's not working, plus 9. And then I have to take this and remultiply that. Okay, so then I would have to do this one. So, I mean, it's totally possible. It's just a lot of extra work. And then x squared, 6x squared. Oh gosh, my finger's not working. 18x, 9x, and 18. And then we just combine these like terms and that's our answer. Okay, we have this other rule that just lets us fill things in. So let me kind of show you. So in this case, this is what it should look like. And I hope I have them all correct off of the top of my head. So what this does is I'm going to have a cubed plus 3ab squared plus 3. Oh, see if I've already messed up. That doesn't go there. This goes there. And I'm running out of room. Okay, so this is what it looks like. So really, what we want to do is we're just going to be plugging things in. So this first one will be A. This first one will be B. So then I just go through and fill them in. So I'm going to just follow the same formula. So I'm going to have x cubed plus 3 times A squared times B. Oh gosh, struggling. Plus 3 plus 3 times x times 3 squared plus 3 cubed. Okay, and then from there we solve. To me, that's really overwhelming. So you see I have these plus signs. I just kind of put my arm over things that I'm not working with so I don't get confused. So this x to the third just stays because I can't do anything with that. But now I have to do this whole thing, multiply those all together. So I'll have 3 times x squared, which is 3x squared, times 3. So that actually turns into 9x squared. Okay, and then now we'll come to this next one right here. I have 3 times x, which is 3x. And then I have this squared. I have to put that through. So sometimes I'll just make myself a little note of what that actually is at top. So I have 3x times 9. That's 27x. And then 3 times 3 times 3 is 27, I think. That feels right. Okay, so really we're just trying to break it down into portions. So it does get a little confusing if I have, like, say this up here, we're actually a 2x. So I'm going to erase this and I'm going to go back and fill it in as if I have that 2 there. All right, so now I'm going to go through. So parentheses are going to be really helpful for you just because in this case, that squared doesn't just go to the x. That also goes to the 2. So when I put it in parentheses, I know this has to distribute to both of those. So I'll go 3, 2x times 3 plus 3 times 2x times 3 squared plus 3 squared. Okay, and then now I just go back and I solve again, all right? So I have 2 squared gives me 4x squared. See how I did that to both? Now here, let's look just at this stuff within this plus sign. So I have this little squared right here too. I'm going to distribute to that and kind of just write it above. So really this becomes 4x squared. Just writing it above is just something helpful that I do for myself. Because now when I go in, I can do 3 times 4x squared gives me 12x squared times 3, which is 36x squared. Okay, now we'll do the next set. So I have my little square right there. So this is actually 9. So I have 3 times 2x, which is 6x, times 9, which is 54. Is it 54 or 56? I think it's 54. And then plus my 27. So I hope that makes sense. There are a couple different rules, but it's going to be the same concept. Is you're going to be given something like this, and there's a formula that you just plug things in. And then we do have notes on those, so you'll kind of know what they look like. I just cannot remember them off the top of my head, and I just didn't think about grabbing it. Okay, and I can help you more with that when you come back if that's confusing to you, since I didn't show you those examples. Okay, the newest thing that we learned is dividing polynomials. So we did learn 2 different ways of doing it. One is a long division way and one is a synthetic. But after Mrs. G and I worked together, it was mainly her. I'm going to give her all that credit, but we talked about it. We figured out we can do everything in just one format, which is called synthetic, which is the way easier option. So I'm only going to show you that one because that's the only one that really matters. Okay. And I hope I can make this example work out pretty good. I did not think to grab an example, so I'm making it up. So if I had x squared plus 4x plus, let's do 8, divided by, let's do x minus, nope, let's do plus 2. I hope that works. Okay, it's a different format. So usually when we did like division, remember we do this and I had like 2 and 4, 8, 7, and I try to figure out things that go into it. That's kind of what we did for long division. Here our setup's just a little bit different, okay? So I'm actually going to draw my division box this way. And this is how it starts. So how I want to begin is I'm going to look at what I'm dividing by. And what I actually want to do is solve for x. And what I mean by that is I'm going to set it equal to 0 and solve it. So in this case, I would just subtract 2 and x equals -2. This is important to solve for x. I could have just known that it was the opposite in this case and be -2, but I want you to get into the habit of solving it because it's going to make more sense in a second. Okay, so this number right here is going to be what I divide by. So I'm going to bring that -2 over here. And now I'm just going to bring down these numbers. So technically this is a 1. So I'm going to have 1, 4, and 8. Okay, I don't need to bring down the x's with me. From here, what I want to do is I need to know that out here, I multiply. I'm trying to write it for you, but it's not working. And inside, I'm going to add. Okay, so I'm going to start by dropping down this 1. First step for all of them, we just bring that first one down. Now, because this is outside of my box, I'm going to multiply -2 and 1 and bring it here. So I'm going to have -2. Here, I'm adding that's inside the box. So I'm going to do 4 plus -2, which gives me -2. All right, and now we're going to start our process over. It's outside the box, so I'm going to do -2 times that -2, which gives me a +4. And then now I add these together, which is going to give me 12. So that didn't work as perfect as I wanted, but that's okay. I always put the last one in a box. It just helps remind me what I'm doing. Okay, I have to erase this side because I drew too big. Okay, so now we need to figure out how we write this out. So this down here is technically my answer. However, we can't just write it in that format. So how I'm actually going to do it is this 1 is going to have the x that's 1 less than what I have up here. And the reason why is because I'm dividing by an x, I have to take 1 away. So really, this just is going to have 1x and -2, right? So it's going to have 1x -2. But this 12 is going to be my remainder, right? This is what is left over, because if I look at this -2, I don't have any more x's. So way back in elementary school, when we divided, right, blah, 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 whenever we came down here and had the last number, generally we'd put it as like a remainder 8 or as a decimal or something like that. That's not technically correct. So how we actually want to write it is we're going to throw a plus sign, and what this remainder is down here, we're just going to write it as a fraction from what we divided by. So how that looks is 12 over x plus 2. Oh, come on, plus sign. There we go. Okay. So let me do another example. This time I'm going to do it a smidgen differently. I'm going to put a number right here in this spot, because this is kind of the new concept. Some kids have named it the Mrs. G. I think that's pretty fitting because I think it's genius that she figured it out. Okay, so I'm going to erase all this and let's start again. Okay, let me come up with another set of numbers. I don't know if I can get it to be perfect. So let's say we'll come here, minus 2x squared plus, let's do 8x minus 4. I really don't know if that's going to work, but it's okay for us to have a remainder. It's good practice. And I'm going to divide by 2x minus 1. We'll go nice and easy. Okay, so again, I'll draw my little box. Like we did last time, I have to solve for x here. Okay, and so I'm going to do 2x minus 1 equals 0. Add my 1. 2x equals 1. Divide by 2. X equals 1/2. Okay, here I don't want you to panic that it's a fraction, okay? I will be one of the first people to say that I hate fractions. But you can do all of this in your calculator, and I promise you it's way easier than long division. Just take my word for it. I promise, I promise. Okay, so now I'm going to drop these numbers down. So remember, this is a 1 if there's not a number there. Okay, first step, drop down this number. And again, I'm going to multiply. Good grief, I need a pen. Add, oh, good grief. Okay, here we go. So I'm going to do 1 times 1/2, which is just 1/2. Okay, and then I'm going to type in my calculator, -2 plus 1/2, right? Which is just, that one's not bad. That one's going to be 1.5. Ooh, this is a horrible example. Hold on. Let me, I'm going to change this first number to a 4. Okay, so then this is just a 2. Let me erase that. That's a horrible example. That's my bad. Okay, 2, which is going to give me a 0. And I'm going to times that. That's a 0, which gives me 8. Half of 8 is 4. Oh my gosh, that worked perfectly, and I cannot believe that. Okay, remainder of 0. So here's the really weird thing about this. So if you'll notice, last time I could just write out all of these numbers the way it was, but now I have this funky fraction. So the extra rule is when I have a number in front of my x by my thing I'm dividing by, and once I get to this point, I have to divide by whatever my denominator is. So if that were a 5, I divide by a 5. If it were a 10, I divide by a 10. So in this case, I'm going to divide all my numbers here by 2. I put this in a box for a reason. We do not have to divide our denominator. Okay, so if this for some reason were an 8, I wouldn't divide that by 2. Okay, I'm just going to leave it as it is. So now, let me erase this stuff over here. How my final answer is going to look is this is going to be a 2. And I don't have to do anything because obviously that's a 0. So I just don't write that in. So looking up here, I have this 3. So I have to go 1 less. So this will be x squared. I don't write an x, right? Because that's a 0. And then I do plus 8. And if I don't have a remainder, I can leave it just like this. Okay. We do have lots of practice problems. We have some assignments on Desmos. They should be in your Canvas. If you need me, have a question, text me. Okay. I am going to write my number right here. I know your mom probably has my number, but seriously, text me at any point, shoot me a picture, and I can help you through it by just kind of solving it for you so you can learn. So write my number down if you need me. And I guess I didn't say, but I'm Shara, just in case you didn't know. Okay, I really hope this was helpful and you are feeling lots more confident now.